Alright guys, and welcome back. Today I want to show you how to find the domain of compositions of functions and composite functions. Let's go. Hey guys, and welcome back. If you haven't done so already, go ahead and subscribe to my channel. Today we are going to be talking about how to find the domain of compositions of functions as well as composite functions. So first thing you need to know is that the domain of a function is simply the set of x values that are possible for the function, meaning the set of x value that will result in an output y after they go through the function. For instance, if I give you the function f of x equals to x minus 2 divided by x minus 1, because this function is a rational function, we don't want the denominator to be 0. So in this case, we're going to say that x minus 1 cannot be 0, which means that x cannot be 1. Also, if I give you the function g of x equals to the square root of x plus 3, since this is a radical function, you don't want anything under the radical to be negative. And so in this case, you would want x plus 3 to be bigger than or equal to 0, which means that you want x to be bigger than or equal to negative 3. And so when it comes to combination of these functions, how would the domain look like? If you looked at f plus g of x, which is equal to x minus 2 divided by x minus 1 plus the square root of x plus 3, as well as f minus g of x, which is equal to x minus 2 divided by x minus 1 minus g of x, which is the square root of x plus 3. And finally, f times g of x, which is simply f of x, so x minus 2 divided by x minus 1, multiplied by g of x, which is the square root of x plus 3. Now, to find the domain of these three combinations, all you have to do is combine the domain of both f and g, the individual function making up the combination. And so I'm going to draw a number line here to show you what happened when we combine those two. And so here I'm going to have the endpoints negative 3 and also 1. And so because of g of x, we want x to be bigger than or equal to negative 3. So we will consider everything on the right of negative 3 to be in our domain, including negative 3 itself. So I'm going to put a closed circle here to mean that negative 3 is part of our domain. But from f of x, we don't want x to be 1. So at 1 here, I'm going to leave it as an open circle to represent its exclusion from the domain. And so now I can write this answer in interval notation as close bracket, negative 3, 2, 1, open bracket to exclude 1, and then open bracket again from 1 to infinity. And so this is going to be the domain for the combination when it comes to addition, subtraction, and a product. All you have to do is combine both the domain of the individual function, making up the function, and you'll be done. Now, what happens when you divide functions? So if I have, for instance, f divided by g of x, then that will be equal to f of x, which is x minus 2 divided by x minus 1, over g of x, which is the square root of x plus 3. And so since this is a division of function, we want the bottom function g to not be equal to 0. On the number line, it would look just like before. You would have an open circle here for negative 3 and an open circle here for 1. And so since you want everything on the right of negative 3 to be included in the domain, I'm going to shade that as well. But unlike before, I'm going to keep the circle at negative 3 open because we don't want g to be 0. And so I'm going to keep the circle at 1 also open because you don't want the denominator of f to be 0. And so with that, I can write this in interval notation, and that's going to be open parenthesis from negative 3 to 1, and then open parenthesis again from 1 to infinity. And that will be it. Next, what happens when you have composite function? When one function is the input to another function. For instance, when you have f of g of x. This expression right here is read f of g of x. And that's going to be equal to g of x minus 2 divided by g of x minus 1. Again, g of x here is considered to be the input to the function f. So wherever in the function f you see an x, you replace it by g of x. And so finally, that expression will become the square root of x plus 3 minus 2 divided by the square root of x plus 3 minus 1. And so when it comes to composite function, you have to watch out for two things. First, the input x should be in the domain of g because x goes through g first, and then g of x itself, the function, should be in the domain of f, which means that the denominator here should not be 0. And so what it means is g minus 1 should not be equal to 0, which means that the square root of x plus 3 minus 1 should not be equal to 0, which in turn means that the square root of x plus 3 should not be equal to 1. And if you square both sides of this equation, you get that x plus 3 should not be equal to 1, which finally gives us that x should not be equal to negative 2. And so with that, we can draw a new number line here, and we have to put our endpoints here. We're going to have to put negative 3 and negative 2. Since the first thing that we want is to have x in the domain of G, we're going to have to shade the right side of this number line starting from negative 3. And we're also going to have to close negative 3 here because of the equal sign in the inequality. So x bigger than or equal to negative 3. Next, since x should not be equal to negative 2, we are going to leave the open circle here open to say that negative 2 is excluded from the domain. And so in interval notation, this is going to look like a closed bracket, negative 3 to negative 2, and then open bracket from negative 2 to infinity. And so with that, we will be done. And if you're wondering about the 1 coming from the function f of x, you shouldn't, because that's not our focus here. And as you can see here, if I were to plug 1 into the composite function f of g of x, then what I'm going to get here is going to be the square root of 1 plus 3 minus 2 divided by the square root of 1 plus 3 minus 1, which is going to give me on the top here 2 minus 2, and on the bottom 2 minus 1, which gives me 0 divided by 1, which gives me 0. So as you can see here, although x equals 1 is not part of the domain for f of x, it is in the domain of f of g. And with that, next time I'm going to talk to you about how to find the inverse wave function. And if you like the way I break down the material here, give me a thumbs up and I'll see you then. Bye-bye.